In this video, we're going to talk about what are reference types and what are value types and how they differ. And this is going to be, I think, probably the first really tricky video in this course. Some people have a really hard time with this topic. And I think the reason why people have a hard time with it is because, and it's ironic, that they are so good at understanding the differences between references and values. And then, in fact, they're so good that they don't even realize that they're doing it. So let me give you an example. Right? Suppose I told you that I read The Hobbit recently, right? The Hobbit, right? Or suppose I told you that I read the book with ISBN number 823380, right? Those are both references, right? I refer to The Hobbit, right? Or I refer to a book by its ISBN number, right? Now that is different than the text of the book, right? I can tell you that I read The Hobbit, and you understand what I mean. I don't have to say I read The Hobbit, or There and Back Again, illustrated by Michael Haig, by J.R.R. Tolkien. In a hole in the ground there lived a hobbit, et cetera, et cetera, et cetera, all the way 300 pages long. Right? I can just have this nice, cheap, easy way to refer to a much longer, much more complicated text. And everybody understands what I mean very naturally. Right? If I write down the words, I read The Hobbit, then people understand that I did not read the words The Hobbit, that I read. They understand that I read the book. Right? So they understand that there was this thing. It sort of had some complicated value, right? These 300 pages. And that I was referring to the book that had those 300 pages. And similarly, when people say, I'm having dinner at the White House, right? Or they say, I'm having dinner at 1600 Pennsylvania Avenue, or I'm having dinner at Barack Obama's house, they don't have to actually give you a model of the house, right? They understand that you understand that they are referring to a house. And that the words are different than the thing that is being referred to, but that they have some connection. Right? So in C#, the problem is that you have to be much more explicit about whether you are talking about references or whether you're talking about values. And in fact, a reference is a special kind of value, just the way that an integer is a special kind of value. And now I've probably lost a bunch of people. So let's take a look at an example. We've got some code here. We saw earlier that variables are not aliases, right? So if I have an integer variable here, right, ABC, I set the value 1 into the storage location ABC. And then I say I have another variable, DEF. I'm going to say that's equal to ABC. Right? If I change ABC to 2, you can see over here, DEF did not change. Right? So these variables do not become aliases for each other, just because the value of one has been assigned to another. Right? Now let's suppose that I do that with an array. Right? We saw last time that an array is a collection of variables that are of a particular size and a particular type, that are indexed by integers. And the arrays that we saw last time all had, one of them had 5 elements, one of them had 3 elements. I'm going to look at an array that only has 1 element. And in fact, you can have arrays that have 0 elements. That's very rare. It's also rare to have arrays that only have 1 element, but it's perfectly legal. Right? So let's say I'm going to create a variable called GHI. It's going to be of array type, and it's going to be this array that has a single element. And I'm going to initialize that element to 10. So if I look at this over here in the locals window, you can see array GHI element 0 is 10. Now suppose I make another variable, JKL, right? And I say JKL is equal to GHI, right? So as you might imagine, right? Well, now these two things are both equal, right? They are both arrays that have an element, a single element, and that element is equal to 10. Right? Now, if I then change GHI, remember we have just executed this statement. This statement has yet to execute. So what's happened? Right? Well, I've now said this is equal to a different array. Right? This is now equal to the array whose first element is 20. So I do that. GHI's first element is now 20. JKL's first element is still 10. Right? Exactly the same as it was with these integers. We did not somehow create a connection between these two variables. Right? When I changed the value of this variable, the value of this variable didn't change. Okay, now here's where things get kind of weird. Two variables can refer to the same array. Right? So I'm going to say GHI is equal to an array whose first element is 10. Right? Okay, so that's changed. Now I'm going to say JKL is equal to GHI again. All right, so there we go. Now I'm going to say GHI's first element is equal to 20. Well, what's going to happen here? They both changed. These both now have a red highlight. When I changed GHI's 0 element, that changed JKL's 0 element. So what the heck is going on here? Well, let me try to draw it. I'll try to draw it on this whiteboard here, and we'll see if we can understand what's going on. Right? Okay, let's suppose that we have a box. Right? We'll call that box GHI. We'll have another box. We'll call it JKL. All right, and let's go back to this statement here. Right. I can something I haven't shown you before is if you hover over this thing, over this arrow by the side here, it says this is the next statement that will be executed. To change which statement is executed next, drag the arrow. This may have unintended consequences. You got to be super careful when you're doing this because it can really confuse both you and the runtime if you suddenly start moving control flow around unexpectedly. But still, I'm going to try this. I'm going to drag it back to here. And now we'll try this again. All right, so we'll say that GHI is equal to a new array that has a single element that is 10. All right, so I'm going to draw that array here. Right, so this is an array. Right, it has one element in it, and that element is 10. All right, and I'm going to say GHI contains a reference to that array. So I'm going to represent that by this arrow. Right? So this guy is now referring to this array. All right. So now what happens when I say JKL is equal to GHI? Okay. Well, what happens is, just as when we are copying one integer variable to another, we make a copy of the integer into the new variable. We're going to make a copy of the reference. Right? This reference is the value that is in here. Well, how do we do that? Well, what is it? It's an arrow that points to this array. So now this guy has an arrow which points to this array. All right, so now we have two variables that have the same value. That value is a reference to an array. So now what happens when I change GHI's 0 element? Well, let's look at what happens here. We say, what is GHI? It is a reference to this array. We wish to change the first element of that array. So that 10 goes away. It now becomes 20 instead. Right? And what happened to JKL? JKL refers to the same array that we just mutated. So what about strings? Right? Let's see what happens here. We've seen what happens with integers. We've seen what happens with arrays. So I'm going to say I've got a string QRS, and I'm going to set it equal to hello. I've got a string TUV. I'm going to set that equal to QRS. So now you can see over here in this window, both of them are hello. Then I'm going to change one of them to goodbye, and the other one did not change. OK, but this is the same situation as we were before in up here, right, where we said GHI was one new array, and then we changed it to an entirely different array. Actually, maybe let's draw that situation out here, right? Because maybe it's not super clear what's going on there. So we'll go back up here. So let's clear off the whiteboard, and let's see what this earlier situation looks like in our boxes and lines diagram. So once again, we've got our box GHI. It's our variable. We've got our box JKL, which is our variable. Right? We say that GHI refers to a new integer array with one element that has 10 in it. Right? Then we say JKL has the same value as GHI. So now this guy has an arrow pointing there. And then we say GHI is equal to a new array, an entirely different array. Right? So we create a new array here, a second array. Right? This goes away. That now refers to that. Right? And so now GHI and JKL refer to completely different arrays. So we've seen that when you copy one variable that refers to an array to another variable that refers to an array, what is actually copied is the reference. And we can change that reference. When we try to change an element in an array, we are changing the thing that is referenced. All right. So what about strings? Right? We have this string QRS is equal to hello. We have this string TUV is equal to QRS. We changed QRS. TUV didn't change. But so now we're in this same situation as we were before. If we go back to our whiteboard, we had QRS equal to hello, right? And then we had TUV also refer to hello, and then this goes away, and this now refers to goodbye. All right, so that really showed us nothing, right? What we really need to do is we need to mutate the string the same way we mutated the array. Right? So let's try to do that. Well, if we try to do that, it says property or indexer string this int cannot be assigned to, it is read-only. This is kind of a confusing error message. First of all, that it says property or indexer when clearly it's an indexer. And also, what is the this int? It turns out that there's a special syntax for creating your own indexer in C#, where you use the keyword this to mean I wish to have an indexer that indexes this thing. It's kind of an odd syntax. We're not going to cover it in this course, but that's what the error message means. It's just saying the indexer for strings cannot be assigned to. It's a read-only thing. Strings are read-only in C#. You can't change them. So really, we're kind of in a situation where you can't really tell whether strings are references or whether they're values. They are actually references under the covers. But since you can't ever mutate one the way you can mutate an array, which is a collection of variables, it's hard to tell that that strings are actually reference types. I mentioned in a previous video that there was a value called null. We saw that if you have a local variable of type string and you're looking at it in the debugger before it's assigned, that the debugger says this thing is null. And there is a reference that refers to nothing at all. It's kind of a strange reference. The null reference was invented. It seems so basic to modern programming, the idea that there's a null reference. It seems like it's odd that it should ever have been invented, but it was invented. It was invented by a very famous computer scientist named Sir Tony Hoare. I've met him. He works for Microsoft Research. Super nice guy. He refers to the invention of the null reference as his billion-dollar mistake, because the number of times that people have accidentally used the null reference improperly and caused their programs to crash, he estimates has caused over $1 billion of damage to the economy. I think that estimate is low. I think it's a many, many billion-dollar mistake. So rest assured, he feels bad about it. He understands that it was maybe not the best possible design, but it's a very pragmatic design. Right? So it might seem odd to say that there is such a thing as a reference that refers to nothing, but that's what we've got in the language. So if we take a look at this thing, okay, let's step through this in the debugger here. Put a breakpoint there. All right, we can say, we've said that QRS is equal to hello. We're about to say that TUV is equal to QRS. Right? So now these two things are referring to the same string. Now I'm going to say QRS is equal to null. You can see over here. Now this becomes null. You'll notice this is not in quotation marks anymore, right? Whereas hello is in quotation marks down here. This is not the string null, N-U-L-L. This is not even a string at all. It's not even the empty string. Right? The empty string is at least a string. The empty string has a length. It's 0. This isn't even a string at all. So you might ask yourself, well, what happens if we try to get the length of the empty string? And the answer is we get an exception. And this says null reference exception was unhandled. Object reference not set to an instance of an object. One of the most common questions amongst beginners on Stack Overflow is, I got the exception, object reference is not set to an instance of an object. What's going on? Well, what happened is you ended up with a variable that was null. You tried to get a property of that variable, such as its length, and something terrible happened, right? Namely, this exception happened. So again, never ever do this, right? If this ever happens, you've got a bug in your program. Any reference that you try to dereference, right? That you try to find the thing that is referenced by it, that thing must be a non-null reference. So performing an operation via a reference, such as trying to get its length, or trying to get an element out of an array, or trying to get a character out of a string, all of those things are called dereferencing the reference. And dereferencing a null reference is an error at runtime, as we've just seen, right? You can't do operations on this thing. It's like an arrow that points off to nowhere. Now, on the subject of reference types and value types, people often say, oh, well, the difference between reference types and value types is that reference types always go on the heap and value types always go on the stack. Now, you might wonder what that means and if it's true. I'll tell you right now, it is not true. People say that all the time. And I want to give you a brief background on that, just so that you can be resistant to this myth when eventually somebody tells you it. I said before in this course that C# was designed so that you don't have to worry about the variables, where the storage in memory is associated with those variables, how long that storage lasts, when it's reclaimed, all of that stuff. The language and the runtime take care of all of those details for you. But behind the scenes, there's a long-term storage pool, which is sometimes called the heap for historical reasons. And there's a short-term storage pool, which is sometimes called the stack for historical reasons. And there is a belief that has been unfortunately encouraged by some not entirely clearly written early documentation that said that instances of reference types go on the heap, and instances of value types go on the stack. And that's not actually true. And it leaves out entirely the question of where do the references go, because references are values too. So I don't want to get into all of the intricacies of how this myth is true and how it's false. I just want to be clear that if somebody tells you, oh, reference types go on the heap, value types go on the stack, they are probably reasoning from incorrect premises. So that's just something to keep in mind. Now, in our next video, we're going to take a look at a slightly different aspect of reference types and value types. We're going to say, how are reference types and value types different when we compare them for equality? And what are all the kinds of different ways that you can compare things for equality in C#? So, summing up, variables store values. There are some types, which we call value types, things like int, double, char, bool, right, where the variable just stores the value, right? There are some things, arrays and strings are the ones that we've seen so far, that are reference types. And if you have a variable that is of reference type, the value of that variable is a reference to the thing being referred to, the string or the array or whatever. Which means that you can have, just as you can have two integer variables that have the same integer in them, you can have two variables that have the same reference in them. Right? They can refer to the same array. And that means that if you change an array that is being referred to by two different variables, then those two different variables will both kind of see the change, right? Because they're both referring to the same thing, right? The same way, if we had one variable that said 1600 Pennsylvania Avenue, and we had another variable that said the White House, and we painted that, we painted the front door of that house, both of those references would see that change. If you went to the White House or you went to 1600 Pennsylvania Avenue and the door had been painted, no matter which reference you chose, you would still see the same thing. All right, and finally, never attempt to dereference a null reference in any way. Doing so will cause the program to crash and die.